Okay, good evening, everyone. So let's begin our evening's topic about swarming and the causes, benefits of swarming, as well as prevention strategies. So before we dive deep into the topic, I just want to briefly mention that we will be running these meetings weekly on Wednesdays, and if anyone wishes to join, you can find my details in video description. Just text me and I'll add you to a messenger group or to a Facebook group where you can get notifications about upcoming meetings. So let's just start our discussion, and all these findings are based both on literature and some observations in Lithuanian beekeeping practice. So let's begin with the main concept that we have to get our heads around is what is swarming. So to put it simply, it's a complex process and it has several stages that happen in the hive, which are driven by several factors. That's environmental, social, physiological, and even molecular factors. And swarming, in essence, is a way for a colony to reproduce itself, to expand itself, and to just how to put it, I think just to get their population growing and not to die out. So when we think about swarming, it's a way for them to split, it's a way for them to reproduce, but what are the factors that influence their decision when to start swarming? So there are several factors as we discussed. So first of all, there must be a huge or at least some nectar flow, which causes the colony to grow as bees are bringing back in nectar, as they are gathering pollen, etc. They are feeding the queen more, so she lays more. The bees are well fed, larva is fed, so you have a lot of brood is hatching, and the colony is just booming and starting to overfill with bees. And that's the rapid colony growth that is needed in order to swarm, because small colonies, they are not able to, small colonies are able to swarm if under certain conditions, but still we need a lot of bees in order for this to happen. So this rapid growth leads to overcrowded hive, and it's been observed that if the concentration of bees reaches more than 2.3 bees per milliliter, the bees start to think about swarming. They start to think that they are overcrowded. They have too many bees that there can fit in the hive. So what is the natural response to that? Okay, so if we are too many in the hive, we have to split in order to free resources, in order to continue building up, because if we are overcrowded, we can't reproduce anymore, and that leads to just limitation in the number of bees, and we want to have as many bees as possible. Another thing is that, let me maybe just draw this thing. Another thing is the reduced queen pheromone. So if we imagine the colony population from the spring, it starts to grow. So let's say in the beginning of the season, we had, let's say, 10,000 bees. So what happens in a month or 40 days? The colony rapidly grows to, let's say, 40,000 bees. And we know that the queen, she emits a certain amount of pheromone. Let's call it a constant, certain amount of pheromone. So if we are thinking in the beginning of the season, we have this pheromone split among 10,000 bees. But what happens when the colony size increases? A lot of more bees are there. So what happens? This pheromone, the queen's pheromone, gets distributed among even more individuals. So the presence of the queen appears to be less in the hive. And this is another factor that is leading the bees to think, okay, so queen pheromone is down, so it must mean that we have a lot of bees in the hive, and the only thing to how we can proceed and grow is to make another queen. So that's one of the factors. Another factor is shift in the worker and larva ratio. So when you imagine in a colony, let's say there are when a strong colony during the season, there are around eight, let's say 8, 9 full deep frames of brood, because if we consider the queen is laying 2,000 eggs per day, let's say. So it takes, if it takes 21 days for the bees to hatch, so the queen operates approximately in 8 to 9 hives. So one deep body hive. It's the optimal size for the queen to work in. So if we consider that and the number of bees growing, so what happens, there are a lot of more nurse bees in the hive than there are larvae to be fed. So that's another signal. If we have overcrowded, if we have a ratio between worker nurse bees and larvae, so it means that the bees are able to feed more larvae than the queen is able to produce. So overall, all of these uh, factors lead the bees to a signal, as I said, lead the bees to a signal that the queen has reached its peak. So there are more bees than they can feed the larva. And the only way the colony can feed even more larvae is to raise another queen. So basically, to raise another queen, they have only one solution. They have to swarm. So when they swarm, let's say the queen was laying 2,000 eggs. When they swarm, they get second queen, which starts laying. So she starts laying also 2,000 eggs per day. So in total, now we have 4,000 eggs laid. So when you compare that to a single queen, now we have two queens. So the colony overall has better chances of survival and has better chances of distributing its genetics across and to pass on their genetics. So basically, that's what we think they are thinking is to these factors contribute to them thinking that they need to expand or make another queen. So these are the main factors that stimulate the bees to swarm. Of course, there can be many others which we don't yet know about, but we are still to find them out. So we talked about the mechanics and what causes the colony to enter a swarming state. But what could be the signals that the colony is starting to prepare to swarm? So in literature, you often find several signals, several signs that you can follow to identify if the colony is in the swarming state. So one thing is decreased queen egg laying, but that's not a very valid and solid point for swarming prevention. We are talking about swarming here and how it works. So of course, before swarming, bees feed the queen less so that she's able to fly, the old queen that she's able to fly. But it doesn't help us to determine when the colony is gonna swarm because we can't uh, observe this at the moment. Another thing is food stockpiling, of course, when there are nectar flows going on. The bees collect a lot of nectar, a lot of the prepare honey stores because the colony has to have enough food to swarm. So when the swarm swarms, it basically takes a lot of honey and it still has to leave some of the honey for the remaining bees and for the remaining queens, so it has enough stores to survive and to live on until they have enough worker bees that can collect these resources. Another signal that we can understand from that the colony is in a swarming state is the mass rearing of queen cells. And as you can see in this picture, here are queen cells. And it's different from supersedure or from emergency queen cells because swarming queen cells are always located at the edge of the comb. So it's either on the bottom or on the sides of the frame. And why is that? So it's been looked up a little bit by scientists, and what they think is the reason when the colony gets congested. So as I said, it's being overcrowded with bees. There are a lot of bees on the sides of the frames and etc. And the queen gets pushed rather to stay in the middle of the frame, and she doesn't get to walk around the edges. So what happens? The queen, she has these feed pheromones which get distributed when she's walking. And what happens is when she's walking only inside of the frame, there is no pheromone present on the edges of the comb. So the bees, when they don't feel that when they feel that there is no pheromone anymore there, they start to uh, build these queen cells on the edges of the comb. So that's one of the explanations that scientists have come up with, is that the queen stays inside and there is no pheromone on the edges, and they just start rearing these queen cells here. Yeah, and yeah, reduced feeding of the queen. So we already talked about that. So these are the signs that they are definitely in the state of swarming and they're soon to swarm. We'll later touch upon other visible signs that we can follow to identify when the colony is gonna swarm and to know a little bit more in advance when is the colony gonna reach its peak state, so we can prevent swarming before they even draw out the queen cells. Because if we are coming to the hive, we didn't anticipate that the colony is gonna swarm, and we already come into the colony and see the closed caps of these queen cells. The colony could have already swarmed, because when we have already queen cells with queens present, at least larvae present in these queen cells, the colony is it's already too late. Well, I wouldn't say it's too late, but we should have done swarm prevention a little bit earlier, even before the queen cells have been started to rear, because it will take a lot of effort to get rid of all of them. And when the first queen cell gets capped, the old queen, she then can already leave. So it doesn't even need the queens don't need to even to hatch, and the swarm can and the old queen can swarm. So we'll talk about that a little bit later. Regarding how the swarm flies, if we are also focusing a little bit more on the theory. So the main idea is that the scout bees lead the way, because the scout where the swarm should go, they look around even before for places, for potential places where the swarm should go and where they should build a new colony. So the scouts who know these places, they lead the way, and other bees follow their path. And another thing is, how is the whole swarm being kept together? Because when we see the swarm flying, they are in this ellipse shape or in this ball shape. They are just flying over. And what happens? The queen releases some pheromones that keep the bees together, keep them rather tight. And another interesting thing is, when you see a swarm settles, like for example on a branch or somewhere on the tree, uh, the queen releases another pheromone which just assembles all the bees into this swarming ball, and that's basically done through pheromones. And another interesting thing is if you, for example, have an apiary and your colony swarms, so the first colony of the year swarms and gets somewhere on the tree, on a particular branch, you can often see that the next swarm from another hive also lands on the same branch on the same spot. And why is that? That's because when the swarm lands somewhere, there are traces of pheromones left behind, which they stay for quite a lot of time. So another swarm that swarms out, they feel the pheromones, they feel that there have been bees on that particular spot, so they land on the same area. So that's also quite interesting. So far so good. So we talked about a little bit about overall how the swarming happens, why does it happen, but another reason apart from them just spreading their genetics and being able to increase the colony size overall, there are other benefits for bees. So first of all, it's disease prevention. And what do we mean by that? It creates a break in the brood cycle. So when we consider swarming, let's say the old queen departs when the first queen cell is capped. So for example, let's say the first queen cell is capped and the old queen, she departs. So let's say that day 0. So in the old colony, let's say this is called old colony, this is new colony. So this is only capped cell. So what happens from in day 0, there is still some brood, but what in the queen that is here, it's only capped. So she will hatch out in around somewhere 8 days. So that's, we already have 8 days until a new queen hatches out. And it will take another 2 weeks, let's say, for it to mate and start laying eggs. So plus 14 days, so that will be 20, 14 days, 22 days already until the first egg comes in. And until this egg is being capped, it will take another 9 days. So it will be the 31st day from the date that the old queen left. So we have 31 days a month of brood break. Well, if we consider there's still some brood here, let's say it hatches out because the queen was laying, we still have around at least 10 to 15 days of brood break. And similarly in the new colony, because they have to build out new frames, new comb where the queen can lay. So it will take also, if they will have around 10 to 15 days of brood break here, and they will have around 15 days of brood break here, because there will be like maybe for 15 days the old brood will be still hatching out. So we have 15 days of brood break and 10 days of brood break happening when the swarm, when the colony swarms. And what happens with the brood break? First thing is there is no more brood to be fed. So we have a lot of nurse bees hatching out in the old colony. In the new colony, when the colony swarms, the old queen goes out and a lot of nurse bees also fly with the swarm. So we have a huge nurse bee concentration in the new colony in the swarm, and we have huge nurse bee concentration also in the old colony. So when the new brood when the new eggs are being laid and when the eggs hatch into larvae, we have a lot of bees that feed these larvae. So the new bees, the new generation, is being fed very well. And that's one of the main reasons for brood disease prevention, is good feeding of the brood, because most of the problems come from malnutrition when the brood is not fed well, when there are lots of brood but less nurse bees that can feed the brood. So it causes a number of problems. So this brood break increases our worker bees, but decreases the number of open brood, which has to be fed. So we have better feeding of the brood, which prevents our brood diseases. Another thing is reduction of varroa load. So it's been measured by Buchler in Germany that around 2% of varroa mites die every day. 1 to 2%, they just fall every day when there is no when there is no capped brood present. So what it means, in these 15 days or in these 10 days when there is no capped brood, the varroa mites naturally fall off in around 1% rate. So we already have here 15% reduction and here 10% reduction of varroa mites. And another thing is when this brood break happens during their active mating, active growth period of varroa mites, some of them become infertile. So what happens is their reproduction gets disrupted, and they can't reproduce anymore. So we have a lot of less varroa mites from them falling, and we have even less fertile varroa mites. So we reduce the varroa loads even more. So that's another thing. Another thing would be also nest renewal. So when we consider um, a new swarm, that a colony which swarms, the swarm goes into a new place, an empty hive, let's say, or an empty place where they need to build new comb. So then they renew their combs, they get rid of the old ones, and basically have a fresh start and better hygiene in the hive, because they have none of these old frames which can also collect various viruses and bacteria. Another benefit of swarming is, of course, genetic diversity, which we talked already about, and generally healthier colonies for the reasons that we already discussed. So for the bees, swarming is really beneficial. They get the brood break, they get better fed larvae, they get rid of a lot of varroa mites, they renew their nest, and etc. So for the bees, that's super good. But when we talk about beekeepers, it's rather harmful, because when you consider a swarm, you lose a lot of workforce first of all, because you get your old queen, which was laying, she leaves the hive, she takes together a lot of worker bees that could feed the brood, that could collect honey, and as well, they take a lot of honey stores together with them. Not even that, you also risk of losing that swarm if you're not present at the moment, and at that moment at the apiary, you don't see the swarm going out, you have the risk of losing it. Even if you see, if you can locate a swarm, it might be in a such place where you can't reach, and you just basically are left standing without any capabilities to capture your bees. Another thing is that it might be labor intensive to recover that for the reasons if it's high up or somewhere in a bad position. And it's also quite a disruption to hive management if you have something planned out and a swarm happens, a swarm goes away, you have to rearrange everything. And yeah, and I think that another thing which I didn't mention here is when you take care of the colony for the whole spring, you overwinter the colony, then you try to care for it during the spring. You expand their nests. You look so that they have enough food stores, that they have enough water, etc., etc. And you put so much effort into building up this colony, and to lose your results, your whole work of the spring, just because the colony swarmed, I think it's the most discouraging factor in beekeeping that can happen to one. So yeah, it's better if the beekeepers knew how to handle swarming and to how to prevent it, so not to lose uh, the whole work that was put into this colony. But in order to prevent the colony from swarming, we have to know when the colony is due to swarm. And this is rather simple, but beekeepers must know the practical swarming signals, because we talked about the queen cells, we talked the reduced queen egg laying, etc. But it doesn't give us the practical application on how to actually detect the swarming stages. So when we consider swarming, we have to think about, I would say, either 3 or 4 stages. So the first stage is, it's basically universal anywhere. If you're in the south of France, and if you're in the north of France, and if you're in Germany, Ireland, or anywhere else, these apply to all the bees, all Apis mellifera. So the first signal that the colony is starting to build up, that it's starting to uh, get into the swarming season, is when you find capped drone brood. Just after wintering, the bees are focused on rearing bees. They need a lot of bees, a lot of mass of bees, in order to get started, to get all the tasks settled, to get new generation, which can later on feed another generation. So they need only bees. So after after wintering, the bees are rearing only worker bees. But after they get a little bit settled in, they can start rearing drone brood. So when this happens, you must take note that it's already the first stage of swarming, and you should be cautious about looking for another swarming signal, which is emerging drones. When you see a lot of emerging drones, not 1 or 2, but you see quite a few drones in the colony, you can know that the colony is in the second stage of swarming. And that's actually one of the most critical stages, because you don't want to miss that, because if you miss this stage, you can miss easily the third and fourth stages, and you never want to reach the fourth stage. You rather want to stay somewhere between 2 and 3. So for for the colony to successfully swarm, they need brood, they need drones. Maybe not particularly for the queen that is left behind, the virgin queen, she will need to mate. So the colonies overall in the same region, they start rearing drones so that new virgin queens can mate. And that's basically one of the critical signs, because if we don't have even drone brood, or even we don't have drones in the colony is not able to swarm, because it doesn't know if the virgin queen will be able to mate. But if they are already having emerged drones, they are one step closer to swarming, because they have prepared the drones for the queens to mate. So when we are in the second stage, we already should be thinking of starting to prepare for our swarm prevention. The third stage is surplus workers. So when we considered before the 8 to 9 frames, deep frames in which the queen is working, So if we get a lot of more bees, so it means that there are surplus workers, surplus nurse bees that don't have the work to do. They don't have enough brood to feed. That's another signal for the bees to start swarming. So if we see a lot of young bees, a lot of nurse bees uh, in the honey supers or somewhere else, we can already anticipate that the colony is due to swarm because they have already drones. They are prepared to make the queens, and they have a lot of bees which don't have enough work to do. And the fourth stage, which comes after that, is the drawing of the queen cells. So when the colony draws out the swarming queen cells, it's already too late because we had to prevent it before that. Sorry. We had to prevent this from happening because if the colony starts to uh, draw out the queen cells, it will take us a lot of time because we have to go through the whole hive. We have to check for all the queen cells. We have to take them out. We have to somehow cage or do something to the queen, the old queen, so she doesn't swarm out. And we have to then regularly check up on the queen cells in 7 and 8 days. Um, so they don't build new queen cells. It takes a lot of work to do when they reach this stage. So what we have to do is we have to focus and stay in this area between second and third stage. So when we see a lot of drones, we see a lot of workers, the colony is strong, we have to do something to prevent the swarm. And there are several ways to do that. So we'll talk about a couple of them, but of course, everyone is free to share their own experiences. So first of all, the most ineffective control method that is being used is destroying the queen cells. When we destroy the queen cells, the bees build it again, and it's fight against the windmills because it doesn't do any effect because we just take them out, the bees draw them again. If we even miss one, it gets capped the old queen swarm. So it's basically nonsense to do that. Another thing is to expand the nest or to remove brood. So it might be helpful if the colony is not yet in the fourth stage. We just put the nest, uh, get the queen to lay more. We give her space by removing brood. But there might be other signals, other triggers, which might trigger the colony to swarm. So that could be the queen age, the reduced queen pheromone, etc. So it can work, but it might not be 100% efficient. So removing broods, so we would, for example, out of the colony, if we have a colony here, we just, with the old queen, we just create a new colony. We just take out the broods. We put some extra bees in here. So we form like maybe 3-4 frames of a colony. We can put a queen cell there and just leave it like that, just removing some wood from here and placing maybe wax foundations into the hive. So that's one way to do it. Another way is rather maybe archaic, quite old technique that was used, I think, in the 18th century, 19th century, is just basically removing the queen because swarming happens when we have old queen, and field bees. The bees that work in the field, that they collect nectar, etc. When we have those together, the swarm happens. And in order to prevent swarming, we have to discourage this relationship between them. So what they used to do is they just remove the old queen from the hive, and that's it. The colony would then rear their uh, they would get emergency queen cells, rear a new queen, and just get the old one replaced. And since there is a new queen, the colony is not swarming because the old queen has been removed. But it's rather costly because if we purchase our queens, we are rather tempted not to kill them, but to save them. So this leads to another way of controlling bees, controlling swarming, that is caging of the queen. So what we use often, it's the queen cages, which are in-frame cage. So if we are thinking like we have a frame here, there are cages which are being placed inside the comb. We just cut out some piece of the comb and place the cage here. The cage is made out of queen excluders in between, so the queen stays here behind the queen excluders, and that's a cheese cage in the queen cage for around 20 days. So what we do here is we create a brood break for 20 days, then we release the queen, treat the colony with oxalic acid, so we remove the varroa mites. And what happens also, when we cage the queen, we stop the brood rearing, and then all of worker bees are hatching out, a lot of bees are emerging. So when we release the queen, there are a lot of nurse bees present in the colony, and the brood that the colony will rear is of very good quality because we have a lot of bees, a lot of nurse bees feeding a small quantity of larvae. So it means that the larva will be fed well and we won't have any brood diseases. So it's quite actually a nice method to control swarming just by finding the queen, putting her into the cage, and we get the benefits of both swarming, because we have brood break, we control varroa mites, and the bees even get more honey because they shift their focus um, from breeding broods to collecting nectar. So that's another way to do it, a better way than the methods discussed before. But I think the best way, especially for new beekeepers, is creating colonies, but not with new queens, but rather with old queens. So let's see how it's done. So there are many ways to do that. We'll talk about one just to get our minds wrapped around that. So as we talked before, we have this duo of old queen and field bees. So we need to get rid of that so the colony doesn't swarm. So during the spring, we have here a colony. I want to be drawing supers here. I'll just leave it like this brood chamber. Let's say it's in the position 1, and here we have an empty hive. Let's say there is a hive stand, an empty place, position 2. So here we have an old queen. So the colony, let's say the colony grew. We have a lot of brood already. We have emerging drones. So let's say from the start of the rearing of the brood, it takes around 45 days to reach this stage when we need to split the colony. Because it takes one generation to, let's say if they started to rear brood in the 1st of February, it will take them 21 days to bring first generation. And when the first generation starts to hatch out, they will start rearing drones. So it takes 21 days plus 24 days until we can see emerging drones, So 45 days in total. It might be a little bit less. They might start rearing drones a little bit earlier than the first generation starts to hatch. So it might take 40, maybe 35 days, but around 40, 45 days, that's the time that you should be focusing on from the start of the brood rearing after wintering. So what we do, here we had just the day 0. Here we have, let's say, day 45, when the colony starts to rear brood. And what we do is we have to break this duo between the adult queen and the female bees. So here we bring a new hive, and we simply take this old queen, we find her, and we transfer her into the second hive. We also put some frames here of hatching brood. We put also some honey, and it would be good to place some water there, because all the field bees will be flying out here to their old place. So what happens is we break the duo. There's no field bees here in this second position. The old queen stays there. And what we leave everything else in this hive. We rather place drone comb here, because if we place max foundation, they won't draw it out because there is no queen pheromone there, and they require queen pheromone to build comb. So we replace all these removed frames with drone comb. And we can leave the colony like that. They will rear emergency queen cells. They will breed their own queens and basically get a new queen in 30 days. So it would be good if we, after plus 30 days, we come back to this colony and we check if they have mated queen. So we check for eggs, and we use oxalic acid to treat the colony. We can trickle the colony because we have no brood. We have just mated queen. She's just starting to lay eggs. So we just go and trickle the colony, and we just use vapor, and we get rid of all the varroa mites. And here, when we place hatching brood, 7 days after creating this colony, after making this colony, because when we put the queen here, she starts laying. So it will take 9 days until new brood that she started laying will start to be capped, and it will, a lot of brood will have hatched out. So we will have basically open brood here. So after 7 days, we use also oxalic acid here, and we trickle the colony, and we get rid of the varroa mite population. So basically, that's the technology that can be used in the hives. Of course, there are variations. Maybe we will talk about that a little bit more in upcoming week, about methods to make these colonies with all queens, and maybe overall how to split colonies. We'll have this this topic going on here, but that's the basic method, basic idea of swarm prevention is by splitting out this duo, and we just have to get this timing right. So there has to be drone emerging, a lot of drones in the colony, but no queen cells present yet. We will talk a little bit more about what happens if we have queen cells, what and how we can prevent that maybe next week when we talk about more of splitting the colonies, because I don't want this video to be too long, so everyone can watch it.